Hello and welcome to Module 6. This is Materialized Views. As you can see, Module 6 is a part of a 12-module training that we have. We've gotten the data into ClickHouse and we've talked about writing queries. And now we're going to shift gears and sort of focus on how to optimize these queries. I'll start with a very simple example of how to create a regular view, and then we'll talk about why those aren't so great in ClickHouse. And then we'll spend a lot of time talking about materialized views. It's a way to save your data in separate ways. You only get one primary key. So that's one use case we'll talk about, is how you can store your data and sort it differently. And then the other thing we'll talk about is aggregations. I'm going to purposely not talk about aggregations in this particular module because there's something very special about that. So I want you to focus here in Module 6 on understanding how materialized views work. They are insert triggers that store the result of a query inside another destination table. All right, let's get started. Let's take a look at materialized views. And I'm going to start by looking at, I suppose you'd call them non-materialized views. We just call them regular views or just views. It's a concept that most databases have, where you write a query and the result of that query sort of gets looked at like a table. And it's nice. Like suppose I have a query that I want to run a bunch of times. Like here, for what it's worth in the UK price paid table, the type column has these 4 or 5 different values: terraced, semi-detached, detached flat, and other. And you can see there's different amounts. Looks like terraced is the most. So what you could do feasibly is if you were going to write a bunch of queries that were constantly filtering by terraced properties, you could create a view. And here on the example in the slide, I called it UK terraced property. And then what happens is that UK terraced property kind of looks like a table. I mean, it almost acts like a table. And when you query it, you'd only get back properties that match the result of this where type is terraced. Let me show you an example here. Let's look at how many properties there are where the type is terraced. And then I'll show you how this works. So there's 8.6 million or so on. So I create a view and I call it UK, what do I call it on the slide? Terraced property. And then you put the as keyword. That sort of signals that this is the beginning of the query. And then whatever you put for a query, so if I select star from UK price paid or type equals terraced, that query becomes the view basically. And if you look over here on the side, if I look at what ClickHouse Cloud does, it actually doesn't call it a table. It puts it under a new section called views. And I can click on it. I mean, like I said, it's like a table. I can view its contents. Notice the type column, every single type is terraced. And then I just get back all the other columns. I can query it. I can just, select star from UK terraced property. And I better not do that because that'll be too many. But you can see that I very much can treat it like a table. And same with the count. I can show you that it's the same number of rows. Yeah, that's exactly what I got up here before. Okay, but what I really want you to understand about views is they're not super exciting. In fact, they're not exciting at all, really at all. If you select count from UK terraced properties, it doesn't know what UK terraced property is. It's just like a stored query. So if I select count from that, what I'm really doing is selecting count, and then it's almost like a subquery. Well, here, I'll just copy and paste it to show you that it's exactly this right here. What I'm showing you, this nested query inside the select query, this is how the view gets executed behind the scenes. It's not the fastest way to count the number of properties that are of type terraced. So keep that in mind, that a view is not efficient. In fact, it's actually inefficient. And so you have to have a reason to use one of these. And I have it on the slides here where I show you the, right here, where I show you the query being a subquery behind the scenes. If you fit into one of these categories where maybe the view doesn't change very often, if it changes a lot, you should use a materialized view. If you're not going to use it very often, then it's probably okay. If it's quick, if it's not super resource intensive, it's probably okay. But in general, we don't recommend that you really even use views, but they're a nice lead into something called a materialized view. This is what we recommend you use. If you have a query that you're going to run over and over again, you can create a view of that table and it'll save the result of that query in a separate table. Well, then that makes the result of that query very efficient to retrieve. What a materialized view is in ClickHouse is something that we call an insert trigger. So what happens is when I insert rows in this source table, those new rows will get sent to the select query of my materialized view table. So if I insert 1,000,000 rows into the source table, those same 1,000,000 rows will get run through my query that defines the view and inserted into this destination table that goes with my materialized view. And I want to walk through that. I want to see or show you how it works. I want you to see how it works. A very simple query here. I'll just copy and paste it over here into the SQL console. And what am I asking for? The most expensive house or property in this table where the postcode is DH1, postcode 1 is DH1 and postcode 2 is 1AD. What I want you to notice about the result of this query, not the value, it's 166,000 pounds. That's not really the point. The point is, look how many rows got processed. Exactly 1 granule? How is that possible? Well, if you don't recall, I can show you the create table for UK price paid, and you'll see that the primary key is postcode 1, postcode 2, address 1, and address 2. I just filtered by the first 2 columns in the primary key. That's exactly what the whole purpose of a primary key is to skip a bunch of rows. This query only needs to process 1 granule. If I take that same query and instead of filtering by postcode, I filter by town. Let's pick a town in the United Kingdom. I'll just pick Durham. It's not that this query is slow. It was actually relatively fast. It wasn't as fast as this previous query, but look at how many rows had to be read. That's every single row. That's 28,782,000 rows. I'm just curious to see how many granules that is. That's over 3,500 granules. This query processed 1 granule, and this processed queried 3,500 plus granules. One thing you can do with a materialized view is store the data in a separate way. Use a different sort order, a separate primary key, so that if I was going to write a bunch of queries that filtered by town, I could create a materialized view of UK price paid and store the data twice, basically, is what I would be doing. And so here's what that's going to look like. I'm going to define a materialized view. You can see it's just like defining a view, except you add the word materialized. Well, that materialized view has to go into a table. There is a separate table that goes with the materialized view. And by the way, those are 2 separate components. The materialized view, which I called UK prices by town, is the name of the materialized view, which is the insert trigger. And which table is being triggered from inserts? It's UK price paid. You can see that down here. Whatever the from clause is, whatever the first table is in my from clause, that's the triggered table. If I insert rows into UK price paid, those same rows will go to UK prices by town. They'll get run through this query and sent to this table. The second component is this table, which is a merge tree table. Notice I ordered by town, so it's got a different primary key. And like I said, so if I did this, the data would be sorted twice. I snuck a populate in there because I want this to sort of work nicely. We don't recommend populate, but this is a good starting point because I want you to see what's happening here. And then I'll just show you in a minute. I'll show you a different way to avoid populate. But look what this does. I just copied and pasted that. Create materialized view. So UK prices by town. It's going to take a little bit of time because it got 28 million rows that are now being reprocessed, resorted by town, and put into, well, I don't know where they ended up. It's not super obvious where they ended up. But if I look over here on the left, you can see there's a different category. So materialized views are different. I can click on that. That'll show me some of the, rows in the table. And notice they're sorted by town. Hey, that's nice. Let's go back to the query that I ran up here with where I sorted by, or didn't sort, when I figured out the most expensive house in Durham. Let me run that same query again, except I'm not going to query the original table. I'm going to query my materialized view. And I get the same answer. I get the same expensive house. It took, it was a third of the time, and it only processed 155,648 rows, which is exactly 19 granules. I only had to process 19 granules instead of 1,500 granules. So the query's much faster. It took a lot fewer resources to process. Now the trade-off was I had to store the data twice. I do have two tables. You can't even see the table here in ClickHouse Cloud. If I go over here and type in show tables, one thing you'll notice is my views. This was the regular view. This was the materialized view. This is a weird sort of table name. It's got a dot in front of it, so I have to put quotes around it. If I select star from that table, I'll just grab 10 rows. It looks like my data sorted by town, my UK property data. It is. This UK prices by town is the materialized view. This is the table where that data gets stored. They are two separate components. There are two things that we're not super excited about in this example. By the way, there's the query where I only had to search here. In this example, it was 20 granules. The two things I want you to notice are that I don't want to use populate, and I want to have more control over that destination table. I'm not super excited about this name of this table. And so I'll show you a way to work around that. What I want to sort of reiterate is that the materialized view is the trigger. If I insert 2 rows into the source table, those same 2 rows, they don't just get inserted into the materialized view. That doesn't work exactly because the query usually does something to the data. And like in my example, I only selected 5 of the columns. And so whatever the scenario looks like, it's important to understand that the rows go to the source table as they are, then the same rows get run through the query of the view and sent to the destination table of your materialized view. Now pay attention, if I delete a bunch of rows, there's no trigger. If I update a bunch of rows, that's not a trigger. Triggers only happen on insert. If I delete 1,000,000 rows from the source table, my materialized view or views have no idea what just happened. If I update 1,000,000 rows in the source table, the view immediately becomes out of date. If you are deleting and updating rows, materialized views are probably not a good option for you. There is a brand new feature that is not ready for production yet called refreshable materialized views. And so maybe that might be something worth researching. But in general, we don't recommend using materialized views if you're going to delete or update the source table. Because it's okay if you're happy with the view being out of sync, maybe it doesn't matter, but for most situations it probably is important. In that case, I would recommend you use something called a projection. That's a topic for another training module, a topic for another day. But keep that in mind if you have that situation where you're updating and deleting data, a projection might work better for you. And so, like I had said just a moment ago, we don't like to use populate. You can see that on the slide. It can take a long time. Let me use an exaggerated scenario. Suppose it takes, I put populate here. Suppose it takes 5 minutes to run this query for whatever reason. During that 5 minutes, the trigger isn't set up yet. So during the 5 minutes, any new rows sent to UK price paid would not end up in the materialized view. Well, I don't want to miss 5 minutes of data. So that's one reason why we don't use populate. In fact, it is a best practice to not use populate. Now I used it here. It's nice for demonstration purposes. I'm not actively inserting data. If you're not actively inserting data into the source table, then you can use populate. It's probably fine. But if you're not in that situation, then you have to have a slight workaround. And so I'll show you that here. And the other thing, like I said, is we recommend you use the to clause. What is the to clause? Well, that sends the data to a table that you actually create yourself. This .inner table got created by ClickHouse. I'm going to create this table, give it a nice name first, then I'll define the view. And so let me walk you through what that would look like. Yeah, it's a 3-step process. You define the destination table, you define the materialized view, you wait for the view to start getting populated, and then you go back and insert the historic data because we're not going to use populate. All right. I have a very nice example here. I'm going to create a table called UK prices by town. I even put DEST there in the table name. That's destination. I want 5 columns. It's a merge tree table and it's sorted by town. So that's my primary key is town. So this will be my destination table. And I won't have that .inner thing going on here. And here I'm going to create a materialized view. I'm going to call it UK prices by town _view. And notice I used the to clause. And I said I want the result of this query to go to this table. It's the table I defined on the previous slide. All I'm doing is picking 5 columns and sorting it differently. So I'm going to grab these 5 columns that are going into UK price paid. If you go back a slide, I'm going to sort it by town. This is a very straightforward materialized view. I'm not doing any aggregations or anything. In order to deal with the populate, which I can't use, by the way, you cannot use populate with a to clause. You'll get a syntax error. Is I'm going to pick a time in the future. So let's say today is February 19th and it's 12:25 or something like that. Let's say it's almost 12:30. Well, if I create this view, the trigger will start working right away. I insert rows into UK price paid. They'll get run through this query, but assuming that the timestamp or whatever the date column is the current time, nothing will show up. You'll just get an empty result from this query. But at 12:30, so let's say I wait 5 minutes, and after 5 minutes, the new data coming in is going to, successfully get filtered through this query, which means it's going to end up in my destination table, and my view as of 12:30 on February 19th will be working. Everything will be great for all the new data coming in, and I'll be super happy. The only thing I'm missing is all of the historical. I'm holding up air quotes, you can't see it. The historical data is everything before 12:30. So what I'm going to do is I'll just populate it. I'll just do it myself. I'll just do a simple insert. This is my exact query that I had before. I'm going to pick the same 5 columns from UK price paid, and I'm just going to do a less than whatever time I picked. I picked 12:30. So now I'm going to go back and get the historic data. Well, I don't care if this takes 5 minutes or 50 minutes or 5 days. I don't care how long this query takes. Once it's done, the old data will be in my destination table. The new data is already going into my destination table. And now my materialized view is in sync. You don't have to use a date column. This was just something clever that I did. If you have some other, logic that you can use, that's perfectly fine. A lot of people just turn on their views and figure out the minimum value of the date. You know what I mean? So turn on the view, create the view, it immediately starts inserting data. And then after a minute or two, start looking at the data in the destination table and find the earliest timestamp that made it through, and then go back and do the historical data from that point of view. That assumes there's a timestamp, but most data you're going to do this with has some kind of timestamp. All right, so nice example. What I want you to do in the lab, really there's 2 labs. I want you to see what a regular view looks like. So you're going to write a very nice regular view for the UK property data, and then you're going to do a materialized view. And you're actually going to go through the whole thing. We're not going to use populate. You're going to use the to clause. You're going to do the whole historical data sort of thing. And so it's a nice lab. You'll notice that in the examples in this chapter, I did not do any kind of aggregations at all. And that's because, well, there's a little more work to that. And that's going to be in the next module. So the materialized view that you'll do in the lab won't do any kind of aggregation of data. And to do that, you need to do something special. It's a decent amount of work. And I wanted to separate that from this conversation because materialized views are very important in ClickHouse. So I want you to go off, do these 2 labs. And if you need to, further learn more about materialized view, make sure you sit through the next lesson, which is chapter 7. Thanks.